Hello all and welcome to this webinar and thank you for joining. My name is Bas Hoksberg and I'll be your host today. My colleague Ryan Sainsbury will be presenting this webinar. We expect this webinar to take about 45 minutes. If you have any questions, please use the Q&A or the chat buttons at the bottom of your screen to get in touch. We might answer them on the fly or at the end of this webinar. I see a nice list of attendees and I hope we can make this interesting for all of you. So without further ado, Ryan, let's get started.
Hey, thank you, Baz. Okay, I'm just going to quickly load up my screen. One moment. Hello, everyone. My name's Ryan Sainsbury. I'm a technical project specialist for Pharos Architectural Controls. Welcome, everyone. So today's webinar is going to be about integrating Pharos with a building management system, a BMS system. So just before we begin, today we're going to be specifically looking at 3 different protocols that we support: Modbus, KNX, and Bacnet. And also we're going to be showing you the modules that we've developed for each protocol so that we can show you how to program a Pharos system, to talk to a BMS system using those protocols, and just to give you a better understanding of the capabilities that Pharos has with each one of these protocols. So first off, I just want to start off with a little intro. Just want to quickly talk about what actually a BMS system is. So a building management system is a computer-based control system that controls and monitors a building's mechanical and electrical equipment. So things like ventilation, lighting, power systems, fire systems, security systems. Obviously, when you're developing a system like this, having Pharos looking after the lighting, but being able to integrate with your main building management system is often a request that our customers give us. So we've given you the ability to have Pharos to act in this scenario as a device on the BMS network. So in order for Pharos to give you the ability to integrate with a building management system, we've provided you with a set of I/O modules. So we talked about I/O modules quite a lot in the past. Effectively, they're software plugins for the Pharos control system. You can download these I/O modules for free, pull them into our software designer, and then that will give you an extra set of triggers, conditions, and actions which you can use to, again, integrate with a building management system using the desired protocol. Now, one thing I really want to make clear just from the start: Pharos supports a small subset of commands for each BMS system, or for each BMS protocol rather, and this is intended to give you the tools that you need to obviously integrate with this building management system, but it doesn't overbloat or overcomplexify the programming. So we only support a small subset of commands, but we believe that the commands that we have given you should be enough for you to get integrated with the building management system without making your programming too complex. If, of course, there is a specific subset of commands that you feel is missing, please let us know. We're always learning. We are a lighting control manufacturer, not a building management system manufacturer. So for us, this isn't our area of expertise, but we still obviously want to learn from you guys. So please drop us a question at the end if you feel there's something that we are missing. Anyway, I'm going to go ahead and I'm going to get started with the first building management system protocol that I want to look at today. And we're going to be looking at Modbus first. So we have support for 2 versions of Modbus. There's Modbus RTU and there's Modbus TCP. So Modbus RTU is effectively Modbus but over RS485, so a serial connection. Modbus TCP over IP is Modbus but over a TCP, transmission control protocol transport layer. So basically over a computer network, over a Cat6 network. Now, we've designed the modules to be pretty much exactly the same. So it doesn't matter if you're using the RTU module or you're using the TCP module. If you've used one of them before, you should have no problem programming with the other one. Just bear in mind that the RS485 and the TCP module, they do have 1 or 2 things that you need to set up in terms of, obviously their connection. But as I said, the module itself, the actual programming that you would use within the module is pretty much exactly the same thing. There is, however, a slight difference in some of the terminology used between the Modbus RTU and the Modbus TCP version. This is just how the protocol itself is written. This is not a naming convention that we've used, but Modbus RTU describes a master and a slave relationship. The Modbus TCP version describes a client and a server relationship. Now, one thing I want to make really, really clear, because it can be a little bit confusing, is that Modbus RTU, where it says master and where Modbus TCP uses the term client, they are the same thing. Master, client, it's the same thing. Server and slave, again, in terms of kind of what we do with the protocol, again, it's the same thing. The only difference between the Modbus RTU and the TCP version is just the way that the data is obviously transported. One uses an RS-485 connection, one uses TCP. With the RS-485 connection, you have a bus. So the BMS system will send out something like a read-write command. It'll have a ID attached to it. This is referred to as the slave ID. All of the devices on that bus will get the command. They will internally have a slave ID that's been assigned to them. They will check that ID against the command. If the ID is a match, then obviously the command is for them. Otherwise, the command just is not for them and is discarded by that device. With TCP, it's unicast, so the BMS system just speaks directly to the device that it needs to. In this case, Pharos obviously being a server device and the BMS system being a client device. So in terms of actually how the setup works, you have obviously your BMS system, as I've said, the master client device in this setup. This will send out read-write commands, obviously to read data back from Pharos or write data to Pharos. And once it's done that, obviously it can then obtain information from us, or it can write information to us in order for us to then go off and run a routine. So effectively, when it's writing data to us, it will be triggering us. When it's reading data from us, it will be querying us. It will be getting information back. Pharos, though, in this scenario is obviously the slave and or server device. However, there is also the option to make Pharos the master or the client device. Now, as I said at the start, Pharos is not a fully blown building management system. But what you do tend to find with a lot of Modbus devices, it's quite useful, especially in smaller setups, sometimes for Pharos to act in this way so that it can read and write Modbus data to devices such as UPSs, thermostats, sensors. So again, it's a really, really good option for just integrating with other sensors and other devices. Pharos is not a fully blown building management system. More often than not, if you're integrating with an actual building management system, Pharos is going to be acting as the slave or the server device. But we do have that capability to make it the master or the client, just so that it can integrate with external devices such as sensors and UPSs. So this is a really cool part of what we've developed, and hopefully, with those smaller systems, you'll find that really, really useful. So in terms of actually how Modbus works, Modbus supports different data types. We support 2 input data types and 2 output data types. And the way to think about these data types is they are just data that is stored internally on Pharos when it's acting in a slave server kind of way. So these data types, they're stored internally. You can think of them as memory allocations. With the 2 different data types that you've got quite a lot of different options for how you want them to, how you can use them. Our output coils, we support a 1-bit Boolean output coil. So that's obviously on, off, true, false. We also support holding registers, which can be 16-bit integers as well. So the difference being is that one is a value that can just literally be on and off, and a holding register obviously can be a value anywhere from 0 to 6,533. That obviously, and then allowing you then to have some kind of value which you can change. And again, I'll show you how you can then go ahead and use that and link that up to timelines or your programming later on. We also support input types as well. So discrete input types, again, these are 1-bit Boolean data types. So on, off, true, false. And input registers, again, these are 16-bit integer data types, which again, you can use as a kind of a range, so to speak. So one of the key things that we need to go through is that, if Pharos is acting as a slave server, it can set any of its input and output data types. The holding registers, though, can be read or written to by the master or client. So the master can obviously write to a holding register that would allow us to trigger from that device. We could then use that as a variable, which I'll show you later on. But coils also can be read and written by the master client whilst discrete inputs are read only. The master can only read those discrete inputs. Coils, though, those type of on, off, 0, 1, Boolean type values, they're generally associated with relay outputs or devices that can be either on or off because they only have two states. If you want to use something like a timeline selection, more often than not, you're going to be using a holding register just because it supports that range of values. So just a basic breakdown. So as you can see, I've got a little diagram here, which hopefully will give you a little bit better understanding of how the actual process works. So we have BMS system here. It writes data to Pharos, could be a holding register, let's say. Pharos obviously is acting as the server-slave device in this scenario. As soon as you write data to Pharos and you change a holding register value, let's say you change the holding register value to 7, Pharos then will obviously trigger from where the data has been written to it. It can then use that value to pick something like a timeline. So you can use that as a variable within our action. When Pharos is acting as the master client, obviously it's a little bit different. Pharos will or has the ability to read data from a device, so it can find out what kind of state it's in. The slave device or the server device will then return that data to Pharos, and if Pharos needs to, it can then trigger from that device and then run its own routine as well. So Pharos has this ability, obviously, as I've already said, to act as the client and the master, as well as the server and the slave, but it can be used to obviously read and write data, but it also can be used to trigger from data as well. So I'm just going to go ahead now and I'm just going to show you how you can get started with Modbus. So first of all, you can hit scripts and modules. That will then bring up our IO module library. All of your modules that you've already downloaded should be there. But if you want to, and you haven't done so already, you can hit the download button. The download button will then bring up a long list of all the modules that we support. Look for the Modbus module that you want to work with, i.e. RTU, TCP. And once you've done that, just go ahead and just click download. You also might want to check as well that you've got the most up-to-date version. As you can just see in the previous window, you have a version and then an existing version number as well. And the existing version is what you have locally, and then the version is the most up-to-date version. So make sure, if you haven't done so already, that you've just downloaded the most up-to-date version. Once you've hit download, though, that module will then be downloaded to your module library. You can then go ahead, select it, click new. I'm using the TCP version here in this demonstration. And then you have a couple of different options. So because it's TCP, it has a port number specified. 502 is the default port for Modbus TCP, so you can pretty much leave that as is. And then we just have some extra options as well. So if you want to include some extended logging within the log, you can do that. And obviously it will then just allow you just to have a little bit more information. One of the things that's included with each module is the documentation, which is just shown slightly on the right here. Make sure you have a good read of that. There's loads of information in there that will let you know how you can then use the IO module effectively in your programming. So I'm going to go ahead now and I'm going to set up Pharos as a server-based device. So again, I'm using the TCP version here today. So I'm going to set Pharos up as a server device just by selecting the module. And the first thing that I'm going to go ahead and do is just quickly go through the different options as I've done before. Everything looks good. If you want to turn some of the extended logging on, you can. Again, it will just give you more information within the controller's log. And then I'm first going to have a look at some of the triggers. So we've got two triggers here. There is a TCP server trigger for whenever a command is received. Specifically, there is one for when you want to write to an output coil that's stored internally on the device, or when you want to write to a holding register. I'm going to start off with the holding register first. This is more often than not probably the trigger or the data type that you're going to want to use when using Modbus, just because you've got a little bit more options in terms of what you can do with it here. So first of all, you have to specify a register address. Okay, so this is like a memory allocation. You can think of this literally as just a memory allocation. It's just a number that allows you to specifically pick which type of holding register, or sorry, what number holding register you want. And then finally, you have the ability to set a very specific value, or if you wanted to, you can set it to any, and then depending on what number or what integer is written to that holding register, you can, of course, then turn that into a variable, which can be really effective in your programming. So I'm just going to use a start timeline action here, and I'm going to set that to variable 1. So I've got register address 0. That's what the BMS system is going to need to write to. It will write a value to that register address. And then obviously, because I've got the trigger set to any, it will then pass that value that has been written to that holding register. It will pass that as a variable, and this will allow us to then pick a timeline. So more often than not, holding registers really, really good if you want to use variables within your actions. Just obviously make sure that you have it set to variable. You'll also need to make sure it's variable number 2, because variable number 1 will actually be the register address. It's really, really important. So make sure you have that set to variable number 2. The other type of trigger that we have is for an output coil. Now, as I explained earlier on, output coils have the ability to be in either an on-off state. They're Boolean type values, so 0 or 1. You do have an option for any, again, to use it as a variable, but more often than not, I think what you're probably going to do is just use one of the 2 options that are available, so off or on. Again, you will need to make sure that you pick a register address that's associated with that coil. But again, you can then link that to an action. I'm just going to show basic actions today. Obviously, you can link whatever Modbus trigger you want to whatever action you want. But just for today, I'm going to use master intensity. So when I get a off command, what I'm going to then do is then just effectively wind the master intensity down. And then when I get an on command, I'm just going to wind the intensity up. And yeah, that's pretty much it. It's very simple. We have 2 triggers when we're working in the server mode. And of course, you can use those as shown on screen. One other thing as well that I think is quite important to state, the IO module instance, the IO module status variables, which will appear in the web interface, will show you what values those data types have. So if you load that up, you can have a look here. You can see the current values that have been set to both your coils and also your holding registers, just so you have an idea of obviously what values that they contain. Particularly useful if you obviously want to see if your BMS system is writing to it correctly. So as I said, we have the ability to have Pharos set up in a server or a slave mode, but also we can act as a client as well. So here I'm using the client module. This is actually a separate module. You'll need to go download this as well. But of course, you can do that just by going to download, just making sure you have the right version, the most up-to-date version, and then just pulling that into your project file. Once you've done that, you will need to set up 1 or 2 different options. First of all, you will need to obviously set up an address for any server devices that you have on your network. Typically speaking, what you would do in this scenario is you would have a separate module instance for each server device on your network. I'm just going to work with 1 device today, but as you can see, I've set up an IP address for it just so that it knows whereabouts on the network it should send its commands to. Again, we've got some extra options here, just such as the port number, which again, if you want to, you can change, but it's probably recommended that you don't. You just keep it as the default. And then finally, we also have some other options, such as a reply timeout. So if we haven't had a reply from the device and we want to set a timeout, we can do so. That will then fire a trigger. And obviously, if we wanted to retry that command, we can do so, or we can just run another kind of routine. Again, you've got the same abilities as before, extended logging, just so you can see all the data coming in and out of the device. But in terms of triggers, we have quite a few different triggers that you can use when the Pharos device is in the client mode here. They basically consist of reading, query replies, which will allow you to read back data from the device. But first of all, before we go ahead and do that, what we're going to probably want to do is actually make that read command first. So we're going to have a startup trigger here. I'm going to then use an action to read the data of a holding register on a slave device. Select that. It'll ask me what starting address, or what address rather I want to read, and then how many registers. So I can just leave that set up as is. Once that command has been sent to the slave device should then return some data. We can then use one of the triggers which I described before, the query reply triggers. Once that trigger then fires, it will then pass that data into whatever action we want. Again, just specify what register address we want to get back, and then whether or not we want the range to be exactly equal to a specific value or less than or greater than. The value can be set to any though. Again, this will always allow the trigger to pass that data as a variable. I can then use that as an action to run some kind of routine. So the basic setup I've got here is that on startup, the Pharos client Modbus device will send out a query to the slave device. That slave device returns data to the Pharos system. A trigger fires internally in Pharos saying, okay, we've received that data. You have a couple of different trigger properties just to filter out any information that you don't need. If you want to, set it to any, and of course that will then create a variable. You can then use that variable to, of course, then run some kind of routine. In this scenario, I'm just getting it to start a timeline, but of course, as I've already said before, you can apply any trigger within Pharos to any action that you want, and that obviously includes IO module triggers as well. So as I said before, if you send a command from a client device, from Pharos acting as a client device to a server-based device, and it fails to return any data, we have a trigger called reply timeout. And effectively what this will do, after a given amount of time, if we receive no response, we can either then try to read the data again, or we can just go ahead and just run another routine. In this case, I'm again just keeping it nice and simple for you, just running a timeline in case we don't get a response. This is particularly useful though if you do, of course, want to read data back from temperature sensors or UPSs, and you can get that information back and then obviously run some kind of routine from it. And that's kind of the scenario that we'd be working with. However, that being said, you may, of course, want to write data to the devices as well. So I've set up an astronomical trigger here, something very, very basic. So this astronomical trigger, maybe it will fire at sunrise or sunset. And again, by using the actions, what we can go ahead and do is we can actually write to a slave device. So again, we have the ability to write either coils or holding registers, coils being those Boolean values 0, 1, registers being a 16-bit integer. I'm just going to pick a single coil for now. I'm going to have to select my register address, and then I'm going to have to select the value that I want as well, just to make sure that's configured. But you can do that in the actions properties as shown on screen right now. So just make sure that you have the correct register address set up in the action, and then obviously the value that you want to write. Okay, so that's pretty much it for Modbus. I'm going to move now on to Bacnet. Now, again, I just want to start off with a really basic diagram just to give you an understanding of how you would go about implementing Pharos in this type of setup. So again, you have this client-server relationship, because Bacnet is done over Cat6, it's done over a computer network. So again, same terminology as we've used before. BMS system in this scenario is the client. It's the one that reads and writes objects to Pharos. Pharos obviously acts as the server device. However, in this scenario, or rather using the Bacnet IO module, we only support Bacnet acting as a server. It can't act as a client like it does in Modbus. It's only going to be a server device, and we only support the Bacnet over UDP, so over a computer network. We don't support any other protocols. So predominantly, Bacnet communication is done via unicast. However, it is broadcast for discovery. So if it needs to discover a device using a whois command, it will then broadcast. But as soon as it's found those devices, after that, it will then just start unicasting to those devices. So like before, you have your BMS system. Normally, there's some kind of switch or gateway that sits between Pharos and the BMS system. It's not normally a direct connection. And then obviously you have your Cat6 network after that, your computer network. Pharos sits on that with an IP address, and then the BMS system can talk to us through the gateway. The setup is pretty much exactly the same. You have objects which are installed internally in Pharos. The the BMS system can read or write to those Bacnet objects, allowing the BMS system to obviously trigger us, or of course allowing the BMS system to read data from Pharos. There is one other thing though that I need to just quickly say is that we support something called COV, change of value notifications, and effectively that's where Bacnet wishes to receive COV notifications every single time a value is changed on a server device. So I'll go through this in a little while, but it's a really, really good method to basically push data back to the BMS system rather than having the BMS system poll us for data. Before we come onto that, though, I just want to quickly talk about some of the Bacnet objects that we support. So there are 6 different types of objects that we support. Again, it's a little bit like Modbus. You can kind of think of it in the same way. These objects are objects that are installed internally in Pharos. They have different types of values, and depending on what values have been set or changed, you can, of course, then get Pharos to run some kind of routine, trigger it, or if you want to, you can use them as a status for something. The different values that we support are listed on screen right now. So we have analog inputs, analog outputs, and analog values. Inputs and outputs can be thought of pretty much like an input and output, on a Rio or something similar to that. But the value types that we support are all 8-bit integers. So we have a range of 0 to 255. And then again, we have a binary input, binary output, and binary value. Again, these are on, off, true, false, 0, 1 type of values. Okay. One thing that's really, really important when you're using Bacnet, though, is that you must initialize any objects that you wish to use on startup. Okay, really, really important. I'm going to show you how to do that in a little while, but you have to do that with Bacnet as opposed to Modbus. Again, it's just how the protocol works. And also, each value that you initialize needs an object name description when it has been initialized. And again, I'm going to show you that in a little while. So let's quickly go back to COV, change of values, because this is a really useful feature when using Bacnet. So the building management system, when it loads up, it will make a subscription request for an object to Pharos, and it will say, okay, every single time that this object has been changed, this value has been changed in this object, I want to know about it. So as soon as we've received that request, we handle that all internally, and then as soon as a change occurs within Pharos, we then push that data back to the BMS system. And this basically means that the BMS system no longer has to poll Pharos continually to get the status of a certain value, which it typically may have to do if we weren't to support this feature. So just so you're aware, this is all handled internally within the module. You don't need to set anything up. All you need to do is just make sure that the BMS system makes that COV subscription request when it boots up. Obviously, Pharos will, as I said, handle that internally. Okay, it will know specifically, okay, it wants the status of this object every single time this value updates, and then I can push that data back to the BMS system when a change occurs. So let's go ahead and start by looking at the Bacnet module. Again, like before, make sure you've got the most up-to-date version. We are updating these quite regularly at the moment. You can download that from within Designer, just as I've shown you before, just by hitting the download button. As soon as you've hit download, it'll put it into your project file. And then, of course, you can go ahead and then click new and set it up. So again, just like with all of our other modules, there are a couple of basic properties that you may need to set up. So there is, obviously a port number, an instance number. But one of the important things that you probably want to look at when using this module is actually the device location and the device description. This will effectively show up when the BMS system does a discovery, and it will show, whatever location description you enter into this property. So give that a name. And then give it a description, just so the BMS system, when it does that discovery, it can have something useful come back. And once you've done that, you can then go ahead and you can start to use the module. So the first thing I want to show you is just a really, really basic action. So first of all, as I said before, on startup, the first thing you need to do is you need to initialize any objects that you wish to use within your programming. So we have an action to do this. It's called initialize object. Simply select it, and then you'll have the option to pick from different object types, which I've already talked about: analog inputs, outputs, values, etc. Go ahead and select the one that you want to use. For now, I'm going to go ahead and just use an analog input. You have an instance number. Again, this is similar to the register number. It's just an allocation of memory or allocation of a number of an object stored internally within Pharos. You obviously then need to give the object a name and a description. Just fill this out as you would, just with a name and a description. Doesn't need to be anything special, but it does need to be filled out. And then finally, you can set an initial value for that analog input. 0 being effectively null, and then obviously numbers after that having some kind of data. You can specify a unit within Bacnet, so we do support the units. However, this isn't needed. You can just support no units, but if there is something specific that you're working with and you need that unit to be reported back to the BMS system, you can specify a unit for your value. At the moment, though, no units is fine. So at startup, I've gone ahead and I've initialized that object. Brilliant. And now that object will be created on Pharos on boot, which will allow the BMS system to then obviously read-write data to that value. So with the trigger that I'm showing you on screen right now, the object value change trigger, whenever a change has occurred to a value, that will obviously then trigger Pharos. And of course, by doing so, you can then go ahead and run some actions. In the object value changed trigger, you have a couple of different options for obviously the trigger itself. So you can go ahead and you can select the object type that you want the device to trigger from. Obviously, we're using analog input, so I'm going to go ahead. I'm going to select that. The next thing you might want to do is select the instance number. We're just using one instance today, so that's absolutely fine. And then again, you have this option to set it to any value changed, exactly a specific value changed, etc., etc. With any selected, you will create a variable. So the idea, again, being similar to what I showed you before, the BMS system changes that analog input value to say something like number 6. That then creates a variable which is passed from the trigger to the action. You can then use that to do something like select a timeline. Again, just make sure that you have variables selected within the trigger. So one other thing that I want to show you now is just how to initialize another object and work with another object. So in this time I'm going to use a binary input rather than an analog value. Again, just like before, set it up with a name, set it up with a description. You'll have to set an initial value as well for it. But of course, it's pretty much like I've already shown you. Just make sure that you initialize that object on startup so that it's been created within the system. Once you've done that, you can then have Pharos trigger from that. So again, just using the object present value change trigger, select the object type that you wish the BMS system to make a change to. You can then obviously go through all the options as done before. Just make sure that you attach an action to it. I've got a master intensity action here. And then once I duplicate that trigger, again, just make sure that the value corresponds to what you would expect the BMS system to change it to. So you can see here that in the top left-hand corner where I've got my triggers, I've got the binary input changed to false, which is going to bring down the master intensity. And then I've got the binary input changed to true, which is then going to do the opposite. And it's now going to bring up the intensity. So that's pretty much it for Bacnet. Again, you know, all of our IO modules now have status variables. So if you go to the web page within Pharos and you go to the IO modules tab, you'll be able to see all of the different types of objects that you've initialized and any values that they contain. Okay, so finally, I just want to have a look at KNX. KNX is the final protocol that we're going to talk to you guys about today. So KNX works a little bit different from Modbus and Bacnet. Our implementation of KNX at the moment is very, very basic. So first of all, let's just have a look at a very basic KNX system. So you'll have your BMS system, and then you'll have your KNX devices. KNX itself has its own bus. Pharos obviously does not have a way to tap into that, so you will need some kind of KNX router or interface. BMS systems generally will speak to this KNX router and device, and then the KNX router, and that will then push information onto Pharos. KNX routers, I believe, can also be used to filter out certain information, which is quite important because KNX works using multicast, meaning that a message is sent out on a multicast stream. Any device sitting on that multicast stream will obviously then listen out to any commands that are sent out on that stream. So with Pharos set up in this way, you'll need to assign it an individual address. In fact, every KNX device will need an individual address, and this will be so that it knows that the commands being sent out from the building management system are indeed for itself, by again just matching that individual address with the individual address that has been sent in the command. Pharos has very basic implementation for KNX that I've already said. Basically, we only currently support binary triggers, so that's just on and off. There are other values that you can send in the KNX protocol. We are looking at supporting them in the future, but for now, we just have the ability just to turn things on and off within Pharos using the triggers, which again, I'll show you in a little bit. But yeah, this is a basic KNX setup, and as I said, Pharos just basically works as a KNX device. It won't act as a BMS system or KNX type BMS system in this scenario. So again, just like before, make sure you have the module downloaded, fill out the necessary information. So things like the router's multicast address, make sure that the port is set correctly. The group address structure and the individual address structure can operate in a 2 or 3 level. You can kind of think of this like a subnet mask, okay? So effectively, this is going to give you a wider range of devices to speak to on your network. For now, I'm just going to use the 2-level type of address, which will just be formatted in this fashion where you literally just have 2 numbers to work with. Which, yeah, again, think about it like a subnet mask, and you shouldn't have any issues there. Again, like before, we have some extra options. If you want to extend the logging, just give yourself some more information, you can do so with the options available within the module's properties. Okay, so as I said, KNX implementation of Pharos is very basic at the moment. We literally have a KNX trigger. Once you select that trigger, you then just need to put in a group address of some kind. You can go ahead and enter that in. That group address, again, will be like an identification for Pharos, or rather an identification for this command. And then, of course, you have the ability just to then send an off command or an on command. Once that on or off command's been selected, you can, of course, then just attach an action to it. Again, attaching whatever action you feel is necessary. And if you want to, of course, you can do pretty much the same thing, but just using an off command. Again, I'm just going to use a release timeline action here just to kind of signify the type of routine that you may want to run. But it won't pass anything like a variable, or it can't handle can't handle any kind of analog value or a 16-bit or 18-bit integer like I've shown you with the previous protocols. It's pretty simple at the moment. So we could also send commands out the system. So if a timeline's been changed on Pharos, let's say by a KNX command, we may want to report that back to the system that it's actually gone ahead and done. So we can go ahead and do that just by having a trigger, like a timeline started trigger, for instance. And then, of course, we can use an action, and that will then send a KNX command back out. Again, just specify a group address. Once you've specified a group address, then obviously just pick what data type you want to send, either on or off. And again, the IO module, we are looking at potentially implementing values with this in the future. If that's something you feel would be a good addition, please obviously let us know. Okay, so finally, I just want to come to a summary about what we've talked about today, just to kind of recap over some of the points that I've made. So Pharos has obviously developed these IO modules that's going to allow you to integrate with building management systems. They do support a small subset of each protocol. If you feel that there are commands missing that you think would be really useful, let us know. But we think we've done a pretty good job in terms of giving you the tools that you need to integrate with a building management system, whilst keeping the module nice and simple and easy to program. These IO modules, though, please obviously make sure that you do some testing with them before you put them into your projects. Not every building management system, we've noticed, works in exactly the same way. So it's really, really important that you just make sure that the modules that we've developed are compatible with the building management system that you use. So that's strongly advised. And then finally, if you want to find out more information about the IO modules themselves, I've already said this, but I just really want to make it clear. You can actually view documentation now in 2.8 by selecting the module after you hit the download button and then going to view documentation. Make sure that you have a read through that. And of course, just let us know your thoughts. So finally, I just want to take the last part of today's webinar just to quickly take any questions that you guys might have. So yeah, if you have any questions, please let us know, and then we'll be more than happy to answer them.
Hi, Ryan. Thanks for this presentation. Some questions did drop by, but I think those have all been answered in the background. Mm-hmm. Possibly if you look through the ones I answered, which I think you can see too. The first one might be relevant to address here. Yeah. The question was, when using Modbus, for example, is there a limit to the number of registers we can control? And what I typed there is, it's with most of the things in firewalls, there's not a hard limit, but of course, at some moment it will become quite inconvenient to try to do it. But if you need firewalls to, have a try to control like a dozen of curls, that should not be a problem. The same is valid for Bacnet or for KNX, right? Firewalls has quite good limits, but of course, don't try to push them. That's, I guess, the way to put it.
Yeah, I mean, I think the way that we've looked at this is we've pretty much tried to follow the spec as much as we can. But basically following the spec as carefully as we can. So I don't know the number off the top of my head. I imagine it will be the number that's stated within the actual specification itself. I think you're right, Baz. Obviously try not to push the system too much. But I've just opened up design in the background here, and already with Modbus, I'm up to 255 addresses. So at that point, I would start to question, maybe there's a way of simplifying the programming as well, because it might not even be a limitation with Faust at that point. It just might be that if you're using all those addresses for all of those different things, maybe there's a simpler way to go about your programming to make it a little bit easier for yourself.
Thank you, Ryan. Thanks. I think I don't see any additional questions coming in, and we're exactly on 45 minutes, so I think this is a right moment to round up. Cool. So thank you for this presentation, Ryan. It was very useful to learn about this and seeing the examples. For those who have, thank you very much for your questions. And if a question comes up after the meeting, please feel free to contact us via support@firehousecontrols.com. Then we can really understand your project and help you out the best way possible. Let me take over the screen. Here we go. Pretty much the same slide at the moment. After this webinar, you will receive a survey where you can provide feedback and suggest possible other topics for webinars. That feedback is very much appreciated. With this, I'll be ending the webinar. I'd like to thank you, Ryan, for presenting, and thank all of you for your attendance. And I really hope to see you next time. Have a good day.